In this video, let's deploy custom control logic as a module. We'll generate a module, add our code to customize the control logic, test it out locally, upload the module to the Viam registry so it can be reused by our future self, teammates, or the general public. I'll drop a link to prerequisites and step-by-step instructions in the description below. I have Viam server running on a Raspberry Pi and I'll be working on a Mac. I have the Pi set up in the Viam app with a webcam, smart plug, ML model to classify objects, and a vision service to detect people. Now I want to create a control logic module to turn on or off a light depending on if people are detected or not. So let's start by generating our module. Let's head over to our terminal, make sure you already have Viam CLI installed, and that you're logged in. Run Viam module generate. We'll name our module control lamp alarm. Build it in Python. I'll leave the visibility private for now. Next, I'll need my Viam namespace. If I go back to the Viam app under settings, I can find my namespace here. And let's make this a generic service. Name our model lamp alarm. We'll enable cloud build. This is going to let Viam build our module using a GitHub action, which is super helpful for hot reloading. And yes, we'll register the model. This lets Viam know that the module exists, and enter. All right, let's change into the new folder with the generated module code. We'll open it up in your favorite IDE and look for the SRC directory, models directory, and find your model name, lamp_alarm.py. This is where we'll add our control logic code. Okay, it's time to develop our module. Viam has defined a class we're calling lamp alarm based on a generic service. You can see our public namespace, module name, and model name here. And for a generic service, you can see 4 default class methods. We have new. This is going to create a new instance of this generic service. This is going to run when the module initializes. We have validate config. We'll make sure the user has provided the required information to configure this module. Reconfigure, this method is called when the module first starts and when the user changes anything about the configuration of their machine. And a do command for any custom commands. We can use this for manual testing, for example. And depending on the resource you selected earlier, we had generic service, but if you selected something different, you might have additional methods in your class. Okay, it's time to write some code. Unless you're following this exact example, your code is going to look a little different, but we'll talk through it a little more so that you can follow the same pattern and apply it to your own code. So let's start by adding our dependencies at the top. We have some imports to support our control loop and provide more visibility during debugging. And my control logic relies on other resources like my vision service, smart plug, and webcam. If you have other external dependencies like libraries or packages, you can add them now. Just make sure to update the requirements.txt file. Next, I'm going to initialize some helper elements. So let's initialize some variables in our class to support our control loop. And then we'll add some helper functions within our class definitions to support that control loop too. Okay, so our new onLoop method, this is where my custom control logic is going to run. So for this example, I'll turn on a lamp when a person is detected with 70% confidence, and then turn off the lamp if no person is detected after 3 minutes, because I'm not made of money. If you have a different sensor or actuator, or you want to do something different, your onLoop is going to look different than mine right here. Okay, back to the validate config method. Remember, this is where we can check to make sure a user provides the required information. Can check data types, return errors if anything is missing. And importantly, it also returns a map of dependencies. So if we go over to the reconfigure method, remember this is where we can get dependencies from that dependencies map and then cast each resource according to which API it implements. So in other words, we're initializing an instance of our resources so that we can reuse them in other methods in our class. And we'll also start our control logic here to run in a background loop. And then lastly, we have our do command. I'm just going to include an example of a stop and start command so that we can manually test it. But this can be any arbitrary command that you program. All right, we have our module. Now let's test it. So let's start by setting up hot reloading. We'll create a reload script in the project root directory and make it executable. Set up our virtual environment by running the setup.sh file. And then in the meta.json file, we'll update entry point, build, and path. And then we'll need our part ID. Since I'm using a Mac, but I want to test the module on the Raspberry Pi, I'll need this part ID. And run Viam module reload with that part ID. This is going to register and restart the module. Okay, once that script runs, let's head back to the Viam app. And we can see a new shell service for Viam to connect to our Raspberry Pi and our new local module called control lamp alarm. Now let's create a new local service. We're going to need the model namespace triplet, which we can copy from our meta.json file. The type is generic, and we'll call it controller. And then we'll configure our dependencies. So for this example, we need our smart plug, webcam, and vision service. And these values are the names of these resources in the Viam app on the left here. And save. It might take a few moments to apply those changes. If you run into any issues, you can always look under the logs tab so you can see all the behind the scenes activity, the module initializing, any error messages or log statements would be here under logs. All right. As you're debugging or making any changes to your control logic, you'll rerun Viam module reload, that command there, to rebuild the module and restart the instance on your machine with that latest code. Hey, we're on the last step. It's time to upload our module to the Viam registry so it can be used by our future self and other folks. Let's clean up our README. And then update our meta.json. We can update the visibility to public now if we'd like to. We'll add a link to our GitHub repository and add a short description. And then revert the edits that we made for local testing. So that's under entry point, build, and path. Anytime we update our meta.json, we'll need to run Viam module update from the command line to apply those changes to our module. And then we're ready to commit our module source code to our remote GitHub repository. Now let's authorize our GitHub action to rebuild our module. Let's grab our organization ID and create a new Viam API key. In our GitHub repository where we committed our module source code, go to Settings, Secrets and Variables, Actions, and we'll create two new repository secrets for our Viam key ID and Viam key value. And then we'll head back to the main code page of our repo and create a new release. And publish that release. Once the action workflow completes, we can try out our new module. So let's delete the local service and the local module. We were just using those for testing. And look for our new module, lamp alarm. Configure it. And notice the module is now coming from the VM registry. Okay, let's save our changes, and you can bask in the glory of that hard work. Now you know how to build a control logic module. If you want to use a different sensor, a different actuator, use an army of sensors, or a fleet of robotic arms, the world's your oyster. Let us know what kind of modules you're building and what you want to learn about next.